for the attendance. Okay. Good morning, everybody, in class and online. Okay, we concluded the discussion related to the basics of Python programming, and so we switch to discussing algorithms, properly said. Let's begin with our screen sharing. Okay. Can you read?
Yes.
Yes, sir.
Okay.
Yes.
Very well. Let's begin with begin again with the definition of algorithm. An informal according to an informal definition, an algorithm is a well-defined procedure that takes a certain value or a collection of values as input and produces a certain value or a collection of values as output. So, algorithm can be seen from a certain point of view as a black box in which we have some input and something happens inside the box, and something can be get as output. If we study what's inside the box, we'll find some computational steps such that the output is processed and transformed into an output. In an even more informal way, an algorithm is an instrument to solve a well-defined computational problem. Please be careful with well-defined. Well-defined means that we have a definite set of steps, of computational steps. We have a finite number of operations, and we have a certain output, meaning that if I submit twice the same set of values as input values, I need to obtain twice the same output. So if I feed an algorithm an unsorted and unordered set of numbers, and provided that the algorithm deals with sorting these numbers, of course I need to get always the same output, meaning the ordered, according to some definition, an ordered set of those values. So we have a relation between input and output, and we have a specific computational procedure to obtain this relation, which binds input and output. For example, we have a sequence composed of n numbers, a1, a2, up to an, we must find one of the possible permutations of this. Does anybody know what a permutation is? No?
It's a way of choosing a k element in a k.
Not precisely. Sorry? Okay. Permutation is a mathematical operation, the output of which consists in all possible different placements, arrangement of the input numbers. So, if I have 3 numbers, these 3 numbers can be arranged in how many times? The first number we have 3 seeds. Let's put it this way. We have 3 numbers. Number A2, number A3, which can be also placed as A2, A3, A2, A3, A1, A2, A3, A2, A1. How many different arrangements do we have? We have the number is 6, which arises from the possibility of placing the first number into any of the 3 available positions. So the first number can be written in any. Let's put this way. We have 3 places. We may write here in second place or in the third place. It's okay? Okay. Of course, depending on the choice of A1, depend all subsequent placements of the 2 other numbers. Because if we choose A1 being there, we may have in the second position A2 and therefore A3 will be in third position, or A3 and A2. So that from placing A1 in first position, we have 2 different Of course, if A1 is in second position, we have 2 possibilities. A3 may come in first position and therefore A2 in third, or vice versa, which correspond to this configuration and this. And finally, A1 in third position means that the two empty spaces left can be occupied first A2, second A3, or vice versa, which produces these two final configurations. Okay, so a rule is that the first number has, in this case, 3 positions. The second number may have 2 positions, and the third number is left with 1. There's no other possibilities. Therefore, for every of the 3 configurations, you have 2 and 1. Therefore, 3 times 2 times 1, meaning that you can write the number of permutations as 6 factorial, which I remember, 3 factorial, yes, which is 3 times 2 times 1. Is it clear for everyone? Is it clear for everyone at home too?
Yes, Professor.
Yes, sir.
Okay. Okay. So, among all possible permutations of n numbers, which are n factorial, okay? So, because the first number may be placed in any of the n initially empty places. The second number may be placed in any of the n minus 1 available places. The third in n minus 2. So you have to multiply for each of the n positions. You have n minus 1 positions for the second number, times n minus 2 for the third number, and so on, until you have the last number, which has only 1 position left. Okay, so this is n factorial. So, among these n factorial possibilities, which of course may imply that you have an enormous number of possible permutations, one of them obeys to the rule of descending order or descending or ascending order. You have chosen for your numbers. Of course, you cannot produce all n factorial permutations, because this is a rapidly growing number, meaning that if you want to sort 1000 numbers, you should produce 1000 factorial permutations, among which only 2 are acceptable, which are ascending or descending order. Okay, so this is not the solution, and therefore we need to devise, to figure out some procedures, some computational procedures, for example, which go under the name of sorting algorithms, which may significantly reduce the computational complexity of the sorting problem. And for example, one of the simplest from the logic point of view, not from the computational, because we'll see that from a computational point of view, it's rather inefficient. It's rather cumbersome. Is the so-called insertion sort, which is what you usually apply when you play some card game, in which you take the first card, you get the second, and then to place in the correct position the third card, you must compare with the first two you have. And then the fourth card will be compared to the first three, and so on. So this is how insertion sort, how cards sorting works. Okay, let's skip to a more formal, to a more precise formulation of the insertion sort algorithm. Okay, the idea is the following. Suppose we have these 6 numbers, which are 5, 2, 4, 6, 1, 3, placed in positions 1, 2, 3, 4, 5, 6. In this case, we use the non-C-like indexing of position, but it is this way. And we begin comparing. Suppose that our sorting follows the ascending order rule. So we have our first position will be occupied by the smallest number, and the rightmost position by the largest number. Okay. So our algorithm works this way. We first compare the first two numbers, namely the first number with the second. If the second, the number in first position, position 1, with the number in position 2. If the number in position 1 is smaller than the number in position 2, we change nothing. Otherwise, we swap their positions. Okay, so that position 2 will be occupied by the larger number of the two. Okay. In this example, we have 5 in position 1 and 2 in position 2. Of course, 2 is smaller than 5, and therefore we swap their positions. So that in configuration in the configuration B, we can see that in position 1 we have 2, and in position 2 we have 5. It's okay? Very well. Now we compare 5 and 4. And 5 with 2. So we compare 4 with all preceding numbers. If it happens that the number in position 3 is smaller than the number in position 2, we swap them. If it happens that the number in position 3 is smaller than the number in position 1, we swap them. In this case, 4, of course, to be not smaller than the number in position 1, so no swap takes place, but it's smaller than the number in position 2, and therefore we must change them. It's clear up to now?
Attenzione, prego. Si è creata una situazione per la quale dobbiamo sgomberare l'edificio. Preghiamo di abbandonare l'edificio immediatamente attraverso l'uscita più vicina. Attention please. It is necessary to evacuate this building. Please leave.